Okay, looking at an application of integration. Now, you would have done when you did derivatives that you could work from displacement, velocity, acceleration by differentiating those functions. We can then work backwards by integrating to go from acceleration to velocity to displacement. So we can use that same process but do our integration to work backwards, remembering that we will have that plus c, and you may have to use additional information to solve for what the c is. So if you're told that it starts at rest and at time equals 0 and at the origin, that tells you a lot of information about what the c values are going to be, and you can solve for that. This quick example here is a fairly straightforward one. We've got a particle moves in a straight line, v equals 2t minus 3, so its velocity is that. Sketch the graph between t equals 0 and 4. So we'll pop that in. We had 2t minus 3, so we'll just write 2x minus 3. There's our linear function. And then the next one says calculate the area between 0 and 4 to find the particle's displacement after 4 seconds. Now here's where there's a difference between what we're working out. So if we put the integral in between 0 and 4, see how we've got a negative section and a positive section. So for the displacement, we are not being concerned, like it's an overall displacement, so the negative can come into play there. So we get an area of 4. So our answer there is 4 meters for the displacement. But then the third part says find the total area to find the distance travelled. So now when we're finding the total area, we want to treat this as a positive and add that to the other one. So we need to find where that is going to cross there. And it does look fairly straightforward that it is at the 1.5. So if we then do the integral between 0 and 1.5, we get negative 2.25. So we're going to treat that as a positive, 2.25. We'll then do the area between 1.5 and 4, and we get 6.25. And so then when we add them together, we get an area of 8.5. So the total distance travelled was 8.5 meters, but it ended up being 4 meters away from where it started. So that difference between displacement, your difference between your starting point and your finishing point, or the distance travelled, the actual distance that you have covered as you are travelling. So just be careful to know the difference between displacement and distance, because that'll determine how you're working out your answers in those.